Okay, so looking through a couple of the essays, we're still having a little bit of trouble on a few key features, processes in the protein synthesis reaction. So let's take a look here at this model here, and let's start at number one in the nucleus. So in the nucleus, we have the DNA, and the DNA has the instructions to make the proteins, but those instructions, again, are locked inside that DNA. So we need to get those instructions out. Now that is done using RNA polymerase, an enzyme that can unzip, unwind, and unzip the DNA double helix and start to read one of those two strands. Okay, now the strand that it reads is the DNA template strand. Now, as the RNA polymerase reads it, it also starts building the messenger RNA out of free nucleotides, so nucleotides that are floating around inside the nucleus. Now, once that is completed, the DNA will then zip back up and wind back up, just like how we always kind of picture DNA. The messenger RNA can now leave the nucleus, and it leaves the nucleus through the nuclear membrane, out through the pores. As it does that, and as it gets to the cytoplasm, it's going to get picked up by a ribosome. So that was all transcription. So taking DNA and turning it into messenger RNA, that is transcription. That uses RNA polymerase and that DNA template strand. So now we're going to go from transcription, and we're going to go out into the cytoplasm, go to a ribosome, and once the messenger RNA attaches itself to the ribosome, that's when translation occurs. And so the ribosome is going to then start reading the messenger RNA. Okay, so we're going into what looks like step 4 here. When it moves in cytoplasm, it becomes associated with the ribosome, and then we're going into step 5. So now the ribosome is reading the messenger RNA, and as it reads it 3 nucleotides at a time. So that's called a codon. 3 nucleotides at a time is called a codon, and codons are found on messenger RNA. So as it reads those codons, it calls out and it calls out to the tRNA, and it says, hey, I got these 3 codons, I need a tRNA molecule that is complementary to my 3 codons. And so a tRNA molecule will bring a complementary set of nucleotides called anticodons to match up with the messenger RNA's codons. Now on the other end of tRNA, that's where the amino acid is found. So the amino acid is transferred to the ribosome by tRNA, transfer RNA. And so the ribosome uses and takes those amino acids and starts connecting them together, bonding them together. And as they come in and they get more and more bonded together, we end up with this long chain. So now we're looking at number 7 here, right? So we're at peptide chain is transferred to from the resident tRNA to an incoming tRNA. And we can see that polypeptide chain starting up there. Once the amino acid has been dropped off, the tRNA molecule detaches like we see in number 8 there, and it goes and picks up new amino acids. And the process occurs over and over and over again. So again, transcription happens first inside of the nucleus. DNA is transcribed by RNA polymerase, and it creates that messenger RNA strand. The messenger RNA strand will then leave the nucleus into the cytoplasm, which then it attaches to a ribosome. The ribosome will now begin to translate, and as it translates, it is reading the messenger RNA 3 nucleotides at a time, also known as a codon. The tRNA molecule will match its anticodons to the codons on the messenger RNA. tRNA also brings an amino acid to the ribosome, and the ribosome starts attaching all these amino acids together and will create a polypeptide chain, and that is your process of protein synthesis.